Welcome, everyone, and thank you for joining us for Day 9 of Atlantic Council Live from COP. We're delighted to have a special program today on decarbonizing aviation. Our first guest is Scott Kirby, CEO of United Airlines, who will discuss the ongoing challenges, but also the opportunities for decarbonizing the airline industry. As many of our audience will know, United Airlines has recently made historic commitments, including setting a target to become a net zero airline by 2050. In its efforts to lead the charge toward a sustainable aviation future. So, Mr. Kirby, thanks for joining us today to delve into these challenges. And let's talk first about, how do you do this? How do you decarbonize aviation? What are the main pathways?
Well, thanks for having me here today. And there's really, I think, three primary pillars that we're focused on at United Airlines. First one is sustainable aviation fuel. That is creating fuel that's not coming from fossil fuels, that can be sustainable and is effectively net zero. Second one is technology, and electric aircraft are a piece of that, or hydrogen-powered aircraft, though because of the energy density of those materials, it's unlikely that they're ever going to replace jet fuel in big airplanes flying long distances, and we're going to need sustainable aviation fuel for that. And third, which I think is important not just for aviation, but for the entire hard-to-decarbonize industry, is carbon sequestration. And we're a partner with Occidental on 1.5 and the first large-scale commercial plant in the world for direct air capture and sequestering carbon. And that's a way that, it's just a price, but we can eventually get the whole planet to net zero with carbon sequestration.
So I didn't hear you mention offsets. When I look around, people are always saying, you can buy an offset for this. Why is that not part of your strategy?
Yeah, offsets, they really do drive me crazy because most of the what I call traditional carbon offsets are either not real and or they're not scalable. Most of them aren't real. You see these projects where people say, I'm going to not cut down a forest that's never been cut down in the history of mankind, and they take 100% credit for that, and then they don't cut it down this year, and then they don't cut it down next year, and they take 100% credit again and again and again and again. But even larger than that, we produce 4,000 times as many emissions as we did in the pre-industrial era. There's simply not room on the planet to plant enough trees to cover all of those emissions. And in fact, Yale had worked on the data that if we planted every square inch of the planet with trees that could grow trees, it accounts for less than 5 months of mankind's emissions. And then you're done. You've just shot your only bullet. And the real problem with offsets is 99% of the companies in the world that I know of are using carbon offsets as their way to say they get to net zero. And it's such a tiny drop in the bucket. If that's what everyone is relying on, we will not get the planet to net zero or even close to net zero without using other technologies and if we let everyone get away with carbon offsets.
So how do you scale up? You're talking about a pretty large quantity of sustainable aviation fuels, 17 million barrels to 3 billion or something, and direct air capture is expensive too. Now, United can't do this on its own. What sort of policies does the government need to put in place?
Yeah, so first on sustainable aviation fuel, the government policies, we need to do the same thing for aviation fuel that we did for the electric grid for renewable energy. Wind and solar 20 years ago were uneconomic, and if you read any of the literature from 20 years ago, it said they can never be competitive with fossil fuels. Today, it's cheaper to produce a megawatt of electricity from wind or solar than it is from fossil fuels. And the reason is because there was government incentives to build those industries and commercialize them, industrialize them. At its core, that's what we need for sustainable aviation fuel. We can do it. We're partnered with a number of innovative companies. We've invested in a number of these innovative companies. They know how to do this. They're working on it, but they need investment dollars to build it and scale it up to a size that matters and makes a difference. And the government infrastructure, the architecture, putting the right incentives in place is really the simple key to building this industry and having it work. Because we understand the chemistry, they understand the chemistry, they know what to do. We've just got to commercialize it and scale it to an industrial size.
So is the version that's in the reconciliation bill, is that a policy you think that'll help kickstart things?
Absolutely, we're very supportive of that, and our fingers crossed that assuming the reconciliation bill goes forward, that remains, because and that's to me, some of the best payback that's in the bill, because if you went back and again looked at wind and solar and figured out the payback on those investments from 20 years ago, like there's hardly anything the government's done that's had a bigger payback, and the same can happen for sustainable aviation fuel.
There are a lot of players in the aviation world. There are the airline manufacturers, there are you, the airlines, there are the people who run the airports. Who else is at the table, and who else has a role in decarbonizing the industry?
Well, it's an all of the above. All of us have to, the government, our suppliers, the innovative companies, at their key for sustainable aviation fuel are the innovative companies like Alder Fuels or LanzaTech or World Fuels that we're working with, Fulcrum, that are building this infrastructure. Ultimately, it's going to take even more than that, though, because you got to get the sustainable aviation fuel into the infrastructures, the pipelines, and someday, hopefully, you'll have even big oil producing it as well. But it takes our consumers and our customers. The more consumers are focused on encouraging or buying airline tickets from companies that are trying to do the right thing or that are doing the right thing, the more difference that will make.
So a final question, which is really, why are you doing this? Is this about virtue? Is this about satisfying the customer? Is this corporate social responsibility? These are pretty big commitments and transformations you're talking about.
Well, the honest answer to that is I'm doing it. United is doing it because it's the right thing to do. I've been passionate about climate change all the way back to college before not many people back then knew that climate change was possible. And even then, even the initial articles, people didn't really know, but speculated on it. I recognize how impactful it's going to be. It is the biggest issue that our generation needs to solve. This isn't a we should do it. This is we have to do it. And one of the great things about now being the CEO is I'm in a position where I can, I can make a difference. And when I retire someday, I think we will have built the biggest, the best airline. We'll be acknowledged as the best airline in the world. But I hope that one of my most important legacies is that I played a role in making a difference on climate change, not just at United Airlines, but for the world at large by pursuing things like carbon sequestration, which are bigger than just United Airlines. They're really about changing the world.
Well, we all hope you succeed. Thanks so much for doing this.
Thank you for having me.
Sure. So now we'll be turning things over to Henry Lawson for our next segment today.
So thank you very much, David. And I'm really excited today to have the panel we've got here. Steve Oldman, who's the CEO of Carbon Engineering, who literally sucks CO2 out of the air, not personally, but his machinery does. Jennifer Holmgren, the CEO of LanzaTech, who, as we heard a little bit earlier from Scott, are making sustainable aviation fuels. And George Oliver, who's the chairman and CEO of Johnson Controls. And what you may not know about George, he's also on the board of Raytheon, and he's also was running GE's engine program. So I'm actually going to start with George, if I may. George, we've been through a lot here at Casket, at Blair Castle, at the Blair Estate, on the subject of getting to the net zero transition by 2050. You've been in the industry, and you've been out of the industry, so you've got a little time for perspective here. What are you seeing here?
Yeah, I'd focus on technology and innovation, and having been in the industry for many years of my career, I am very excited about what I see happening, not only within Raytheon, but across the industry as it relates to aviation and fuels. And I think there is a path forward to ultimately get to a net zero solution. I think technology innovation plays a huge role across all industries to ultimately be able to get to the net zero carbon footprint that we're all driving for, and I think the time is now, because I think the technologies exist today that can ultimately begin to get us there. In our industry, in the buildings industry, the global carbon footprint is 40% of the global carbon footprint, and we're reinvesting 75% of our technology investment is ultimately now focused on solving the problem, the problem. And we're positioned today with our OpenBlue digital capability, with all of our domain technologies within heating, ventilation, air conditioning, building controls, all of the building systems, so that as you look at that holistically and leverage technology, data, AI, we can create solutions today that reduce the energy demand within buildings 50%. And more important now, as we look at a solution holistically, how do we now take that remaining demand and create a net zero building solution that actually brings into account the appropriate renewable energy that's required to support that infrastructure. So I'm very excited about innovation technology. It's going to be fundamental to our path to net zero here. And I think with the commitment that we're seeing across industries and the ecosystems that are forming, that ultimately are focused on solving the problem, we're ultimately going to achieve that.
Fantastic. So a bright future, a positive future, and a very important sector in there. Jennifer, you've been working on this for a long time. You told us a little earlier that you've been working on this since your PhD. And so you're very much and you described, your words were, I didn't crack it, so either it's uncrackable or I'm a lousy chemist. And none of us believe that you're a lousy chemist. So tell us what LanzaTech is actually achieving here.
Yeah, so that was a reference to Fischer-Tropsch and trying to make Fischer-Tropsch catalysis selectively produce jet fuel. So my focus now is on selectively making jet fuel from waste resources. So we recycle carbon emissions or directly or captured CO2 and convert that to ethanol, and then that ethanol is then converted to jet fuel. So that's what we're doing, waste to SAF, waste to electrofuel, aviation fuels, waste to everything else we need in our daily lives, like tires and seat belts.
So the capability will exist. It exists and will exist at scale.
We're already doing it now. I mean, we have commercial plants taking a steel mill gas and making ethanol from them. And we've taken that ethanol and made pants, running shorts for Lululemon and, foam for on shoes.
So you're able to do this. And what about the cost? The airline business is notoriously competitive, notoriously low margins. At least that's what Scott Kirby was telling us off camera.
And we agree.
So which of course we know. So how are you? What price are you able to do this for?
We're not able to do it in a cost-competitive way today, but as we scale, we will be able to drive down the costs. And our forecasted costs are that we will be on parity, starting with waste, with today's jet fuel price. But we need to get to scale, and we're going to need another 10 years to get there.
Fantastic. So, Steve, you're able to actually suck the CO2 out of this room and compress it and create a bottle of CO2 for, you were telling us a bit earlier, about $100 per ton. Tell us more about how you actually do this.
Yeah, so I always think it's worth remembering we're trying to get to net zero. And my maths degree taught me this many, many years ago. When you're trying to get to zero, 1 + -1 is also 0. If you have the ability to remove emissions that have occurred in the atmosphere, now you can decarbonize anything, anywhere on the planet, any moment in time. So that's the power of being able to do direct air capture. So what are some of the examples of how you can use that technology to help aviation? So firstly, we can take our CO2, we can combine it with hydrogen, use a process like Jennifer's, and now you make a sustainable aviation fuel that is compatible with the existing aeroplanes, the existing infrastructure, but its carbon footprint was taken out of the air in advance. You've essentially created a recycling of CO2. Or another application, and this one will some people go, but keep using fossil fuel. But if you're going to use fossil fuel for aviation, which works with the existing infrastructure, it's very effective as a fuel type, you have to remove the CO2 footprint afterwards. And when you have direct air capture, you can implement that. So we're partnered in the United States with Occidental and 1.5 to bring that technology to large scale. It's underway.
Underway and essentially leave no trace in the atmosphere, right? What CO2 you put into the atmosphere, you take back out of the atmosphere.
Yeah, it's the same thing. Every day I put my trash out, magically it disappears. And it's the same thing. The effect is no trash outside. And that's what we need to do on climate. The problem we're trying to solve is the volume of CO2 in the atmosphere. So if you can't stop every molecule going up, bring them back down and put carbon back in its place underground.
So George, if I can turn to you. So the airplanes we're going to see in the future by 2050 seem to look very much like the airplanes that we see today, running gas turbine engines, a British invention, I would just add, just very quickly, but we'll let you have it. But a gas turbine engine, much the same way. Are you confident that that these new fuels can actually get used just in this, as a drop-in?
Yeah, from my experience in the industry, and that goes back a number of decades, and then what I see happening today, there's incredible innovation and progress being made. I think as we look at solving these carbon problems across industries, as I said previously, it's important to bring the industry together and understanding the implications, the opportunity, the implications, and work together to ultimately solve the problem. And I think in the aviation industry, as Scott said, you know, given the mission and the safety, making sure that on a critical path of development, that you've got everyone at the table, so that as you're developing and making those next generation developments, that everyone, you know, whether it be not only for the engine operation, but then the overall support that has to be in place to be able to support that longer term is there. And I believe that I'm confident today, based on what I see, that ultimately will be solved.
Cool. So Scott, interestingly, said a little bit earlier, electric has its place in small, slower airplanes, smaller airplanes, shorter distance travel, and hydrogen may have some place in the middle. What are your guys' view on this? Because you're competing for that same hydrogen. You need that hydrogen to be able to produce your sustainable aviation fuel, Jennifer. So
That's a good question, actually. So when we use a steel mill gas or gasified municipal solid waste, I don't need extra hydrogen. So we need hydrogen for when we use CO2. What I would say is, we're going to be using, if we can get to a world that has enough power to create enough hydrogen, I think there'll be plenty for all of us. And what I need to do is de-risk our technology with the feedstocks that are available today. And then when hydrogen becomes available, I can use it.
okay, and how does the panel address the sort of issue of feedstocks, potentially biofeedstocks, competing for the growing food and land use? Is this something where you're actually, for you, feedstocks have to be used for that way, or other options?
Yes, so we're using waste gases like from a steel mill, so those don't compete with food. We use waste biogas project with Sky Energy and Boeing actually don't compete with food. I think we have to be really careful and talk about, you know, we live in a world where we want everything to be like today's very large, everything is centralized, right? You know, big oil companies using the same feedstock to make all the products we use. We're going to have to create a waste world, which means we have to imagine a future where a variety of feedstocks and a variety of technologies have a seat at the table and the world is distributed. That, I think, is an important enabler. Does that mean food crops can contribute to a certain amount? Yes, especially if they have low carbon intensity, if somebody's capturing the CO2 on the back end or if somebody's doing negative emissions. We've got to be open-minded and not let the perfect be the enemy of the good, and aggregate a variety of solutions to get to the future we're trying to create. We cannot turn this into a competition, or it has to scale exactly the way the petro industry has scaled. Can't get there from here if we do that.
Right. So you're hearing it. You're hearing it here first. We've got George, who's actually solving, biting off a 40% chunk of the problem in the built environment. We have Steve here, who's actually taking the problem that we've already created and putting it back in the ground. And we've got Jennifer, who is producing from all sorts of different inputs, is producing a solution to aviation. I'd like to thank the panel here at CASC at the Blair Estate. And with that, we'll hand back to David.
That concludes today's Atlantic Council Live from COP26. Thank you to all of our fantastic speakers. We are so grateful for your participation. Have a great evening and join us tomorrow at 5 p.m. GMT.